Hello everybody, this is Rudra Pradhan here. Welcome to BMD lecture series, and today we will start with prescriptive analytics and that too coverage on linear programming problems. So, let us we start with the kind of structures, and we have already discussed the descriptive analytics, inferential analytics and predictive analytics, and that too we have already discussed details about the business structure and to solve some of the business problems by using the descriptive analytics tools and the inferential analytics tools and the predictive analytics tools. And as a result, we have discussed so many techniques, inferential analytics structures and the kind of predictive analytics techniques through which we have solved some of the problems, and accordingly we have already highlighted how what extent or how many different ways we can analyze a particular problems and come with a kind of solution through which we can actually generalize the business problems, and accordingly we can take a kind of management decisions. So, continuing with descriptive analytics, inferential analytics and predictive analytics. So, the new structure which we start with the concept called as prescriptive analytics, and let me little bit highlight about the particular structure, that is the business analytics classification, and we have a three different structures which we have already highlighted, and that is the descriptive analytics, predictive analytics and prescriptive analytics. And in the descriptive analytics, what we have already done, it is the use of data to understand the past and present business structure or business performance, and in the case of predictive analytics, it is to analyze the past business performance and predict future business requirement. And the topic which we like to discuss today is the prescriptive analytics, and here we like to use the data to have the optimum solution, that to the best action to a business problem. So, that means knowing the past trend, then using the past structure through which you can predict the future kind of requirement, and within the particular past trend and future requirement. So, we like to find a kind of optimality or optimal structure, that is the best action through which the particular problem can be addressed in a much better way, and then management decision can be taken into considerations. So, we are here to highlight the prescriptive analytics, and let us start with the a little bit background about the prescriptive analytics, and it is a part of a kind of structure called as operation research techniques. Traditionally, work techniques are used for having optimal solution to a kind of problems, whether it is a kind of business or is a kind of defense or any kind of socioeconomic problem, and corresponding to work techniques. In fact, many machine learning algorithms are also used in the kind of optimization techniques while solving a business problems. So, now the typical structure is starting with the descriptives, predictive and prescriptives. So, the questions the question which we like to address is like what happened, that is what the answer is through descriptive analytics, and what will happen, that is the answer through which we use predictive analytics, and finally, what should be the best action, that is the optimal solution which is actually going to address through prescriptive analytics. In sum, prescriptive analytics models attempt to solve complex optimization business problems in the kind of modern era or the kind of dynamic business environment. So, now the thing is that we like to know how this particular prescriptive analytics can be used frequently in the context of management, and that to some of the business problem through which you can actually get the optimum solution, that to values of the decision variable through which you can address the business problem in more attractive way, and then we can come with a particular strategy or decision through which you can actually highlight the issue as per the business requirement. And so far as this particular topic is concerned, so we have the following objectives, knowing the constant optimization and linear programming, then knowing the assumptions behind this particular prescriptive analytics tools through that is through linear programming, and we like to highlight some of the application through which prescriptive analytics can be connected and can be used to address the business problem, and identifying problems that can be solved by linear programming and formulate linear programming models, and knowing the structure to have the linear programming solutions. In fact, the whole idea is actually the optimization structure, and so far as optimization structure is concerned, so we can divide the entire structure into two parts. One is called as a constant optimization and unconstant optimization, and most of the instances particularly in the business framework or business related problems, we like to analyze the objective, or we like to analyze the problem with few or more constants. Without typical constants, we can actually cannot generalize the business problems. So, that means in real life scenario or in the kind of business environment, so most of the objectives and most of the problems can be addressed through particular constant or few constants. So, now how we can actually address the particular business problem with few or several constants. So, that we have to discuss here, and then we can address with business problems, or you connect with a particular business problems, and then finding out a kind of solution through which decision can be taken into considerations. Let us start with the particular structure, and so the particular structure is we can start with the linear programming. In fact, the optimization what I have already mentioned is called as constant optimization and or unconstant optimization, and again the particular optimization structure can be analyzed against or can be evaluated with the structure of linear programming format and nonlinear programming format. So, we first start with the linear programming structure, and the particular structure is like we have a business problem, and the business problem can be converted into a kind of models where we can have the kind of objective functions, and then with respect to constants and the kind of condition through which we like to know the values of the decision variables, or optimality of the particular structure through which the business problem can be addressed more accurately, more effectively, and more efficiently. So, without knowing the particular structure, we are not in a position to say the optimality of a particular requirement, and accordingly we are not in a position to address the problem. So, the thing is that starting with kind of descriptive analytics to predictive analytics, we can get to know the kind of past structure, then the kind of present structure, and the kind of future requirement. So, that means altogether for a particular business problems corresponding to objectives and the kind of constant, that means maybe with respect to fewer more kind of variables or the kind of requirements, and then we like to know what is the exact values of the decision variable through which we can actually address the problem more effectively and more accurately. So, that is how linear programming can help us to know the particular situation and then address the problem as per the particular requirement. So, starting with the linear programming, so some of the terms we like to first address, then we like to connect with prescriptive analytic structures. So, the requirements are knowing the optimal solution, feasible solutions, space corner point, then redundant constraints, slack variables, surplus variables. So, these are the things which we frequently use to get the values of the decision variables. So, now the so far as a linear programming is concerned, so there are three different steps altogether. We start with the problem structure, then with the problem structure we can transfer into model formulations, and once we get the model formulations, then we like to apply some kind of optimization tool through which we can get the kind of solution. So, the solution here is to know the values of the decision variables. So, now in the kind of linear programming format or nonlinear programming format, so the basic structure is the objective function and the constants and the kind of condition. So, now since it is a kind of decision making process, so obviously a problem should start with at least two variables, so that we can have a kind of decisions. So, when the system will be more and more number of variables and more number of constants, then it will be a complex process and it will be a challenging process, and then we like to have some kind of thought process through which we can find out the optimality structures where the values of the decision variables can be obtained, and that too we can in a position to address the business problem. And so the idea is to identify the problems that have actually multiple solutions and problem that have no feasible solutions, and then the kind of unbounded structures and problem with redundant constants. So, that means typically what is actually happening in the kind of optimization structures. So, corresponding to a particular problems and that too with objectives and constants and conditions, we may have the solutions, that is the optimal solution, or sometimes we may not have a kind of optimal solution. So, it depends upon the kind of structure, the kind of requirement. Ultimately, if we can get the kind of solution with respect to objective function and constant, that is fine. In case if we are not in a position to get the optimum solution, that is the case where there may be chance of unbounded solutions, there is a chance of infeasible solutions. So, where the solution is not coming because of certain issues, but here in the kind of analytic structures, we like to find out a situation, or we like to bring a particular situation through which the unbounded problems or infeasible solution can have some kind of optimum solution. So, first of all corresponding to original problem, the original requirement, we try to build the models and solve the models and get the look for the optimality or optimal solutions. Once we get the optimal solution, it is fine. That means, in the first end if we get the optimal solution corresponding to the particular model, that is with respect to objective functions and constants and the conditions, it is fine. If not, then we like to bring some kind of feasible kind of structure where we can have some kind of optimality. For instance, means in the simple structure corresponding to objective function, if the constants are not consistent, then by default we may not get the optimal solutions. So, one way to address or to bring the optimal solution is make the constant consistent as per the particular objective. So, so here we in the kind of prescriptive analytic structures, we like to address all these issues and come to a kind of structure where we can have the kind of optimal solutions, and that to values of the decision variable through which we can actually address the business problem as per the particular requirement, and then we can take the management decision more effectively. So, that is how we like to know some of the issues in the context of linear programming. And so far as linear programming is concerned, if the problem is very complicated and very complex, again like predictive analytics and inferential analytics, manually we may not actually understand, or we may not in a position to get the optimality or optimum values of the decision kind of situation. So, in that case we need actually a typical softwares, maybe our softwares may be kind of Excel solvers through which we can actually address the problem, and then we can actually come with a kind of solution through which we can address the business problems more effectively. And in the context of linear programming, so utilize Excel to solve a variety of linear programming problems is the kind of key agenda in this particular structure. So, we the way we have already solved some of the problems that to in the context of predictive analytics. So, Excel in the Excel softwares, so we have used some kind of data analysis structures, but here so far as a prescriptive analytics is concerned. So, we have a solver package in the Excel, and through which we can actually analyze the kind of optimization problems and come with a kind of solution through which we can address the business problem more effectively. And then after getting the kind of output optimality, then we can think about the kind of managerial interpretation, the kind of business interpretation, the business strategy. So, that means technically we like to have the kind of situation, the input kind of situations and the actual kind of scenario, and then with the help of problem, the kind of model and the kind of software, we come with a kind of solutions. Now, we have the problem in initial structure, then the the kind of model, the kind of inputs, and then finally we have the kind of outputs. Now, looking the problem inputs and output, we think which one is the best and how we can address and analyze, and then come with a kind of structure through which we can address the problems as per the particular requirement. And that is how we are here to know the kind of structure about the linear programming. And so far as the solution is concerned, and what I have already mentioned, so the particular problem will start with two variables or more than two variables. So, that means the entire structure can be divided into two different ways, and first way is with a particular particular or with a particular problems, we must have a constant, and that too at least we have two variables and with two constants, then we may be in a position to address the problem more effectively. Or if in case the problem is more number of variable with more number of constant, then it is kind of solid kind of structure through which you can think about the kind of solution, think about the optimality, and that means technically it is a kind of challenging process, and where the analytics will play a kind of excellent role. But if the problem is actually smaller one and the number of decision variable is less enough, then it will not be interesting or challenging, where the rule of analytics may not be so interesting. So, that means we are here to address bigger problems, and where analytics can play kind of better rules to think about the solution towards the particular business problem. So, now so how we have to start with these particular problems, understand the problems, and how to come with kind of optimality. So, that is again the agenda of the discussions. So, here so far as prescriptive analytics is concerned, what we have already mentioned that it is a kind of optimization structure, and so far as the optimization structure is concerned, again what I like to highlight, we have already mentioned constant optimization, unconstant optimization, linear programming, nonlinear programming. Then in the case of optimization, the another way to divide the particular structure can is like this, the maximization kind of problem and the kind of minimization kind of problem. That means once you say that there is a optimality, then obviously there is a kind of objective function with respect to certain constants, and then some of the conditions may be there or may not be there, but the basic requirement is the objective function with the constants, and that too when we talk about the optimizations, either it will be the maximization structure or the minimization structure. How the maximization structure and how is the minimization structure, that we can address here in a kind of LP structure. So, so how you have to means the thing is that when we have a maximization type of problems, so the kind of we like to discuss how is the kind of solutions. Again, when there is a kind of minimization kind of objective, then we again think what should be the kind of solution, and what should be the kind of interpretation and the kind of structuring. So, these are all things we like to address here, and in the typical structure is like this, and means if you talk about the linear programming, that is some of the assumption is also there to address the particular situation. In fact, when we are analyzing a complex business problems or dynamic business problems, and obviously some of the assumption very much requires. It is not in the case of predictive prescriptive analytics, it is also true, equally true in the case of predictive analytics or the kind of inferential analytics. So, it is also here, and the first part of this particular structure is the formulation of linear programming problem, that too with respect to a particular problem. Then think about the kind of solutions, and since I have already highlighted that it can be with respect to 2 variables or with respect to more than 2 variables. So, accordingly we have a 2 different structure of the solution, and one particular structure of solution is called as a graphical solutions, and another particular structure is called as a algebraic solution, that is in the context of linear programming it is called as simplex method procedure. In fact, whether you like to use graphical structure or algebraic structures, that is not our actually main agenda. Our main agenda is we have a kind of problem, business problems, and we like to have some kind of optimality or optimum kind of requirement through which you can actually take a management decision more effectively. So accordingly, so whether it is a graphical kind of structure through which you get the solution or algebraic kind of structure through which you get the solution, that is not actually the kind of requirement, but the requirement is the solutions. In fact, most of the business problem is very complicated, and by the way it is there is a high chance that it consists of more number of variables. As a result, in reality we like to address or we look for the optimality or search for the kind of values of the decision variable, and that for that actually simplex procedure is a more attractive way to get the kind of optimum solution. So, these are the things actually we like to highlight here, and by the way the LP structure is the LP structure is like this. We must have objective function and the constants. What I have mentioned actually, since it is a kind of decision making process, so at least 2 variables must be there in the system to address the kind of situation. Then the structure is objective function with the constant, and again so the objective function can be a single objective, can have a multiple objectives. So, accordingly we have a 2 different structure of linear programming. So, linear programming structure 1, that is with a single objective, and a linear programming structure 2 with multi objective, that is sometimes called as a multi criterion decision making process. So, now how we have to address all these kind of situation, and again how to get the kind of optimum solution, that is actually the kind of agenda here to discuss. So, now the discussion so far as linear programming is concerned, and that to constant optimization. So, looking for the optimal solution to a problem given that certain constant must be satisfied by the solution, and it is a kind of decision making that involves situation in which the set of acceptable solution is somehow restricted, and understand the scarcity, the limitations on the availability of resources, the kind of for the particular business requirement or the kind of business investigation, and looking for the solution that have actually very efficient and feasible with respect to all the constants and conditions, and that to the with the kind of allocation of resources. So, these are the major things are through which we have to highlight, and then so far as solution is concerned, that to linear programming, it is a kind of family of mathematical techniques, and that is called as algorithm that can be used for constant optimization problem with linear relationships. Since it is starts with linear programming, so whether it is objective functions or constants, so the expressions will be in the form of linear. So, we have a kind of structure called as a linear combination, and obviously, so the linear combination will be applied to both objective function and constants. So, that means if the problem will be more interesting with at least 2 variables. So, that means when we will say that objective function, then the linear combination of both the variables will give you the objective function structure. For instance, let us say x1 is the variable and x2 is the variable, then the objective function will be like C1 x1 plus C2 x2. So, So, that is how the the kind of coefficients to x1 and the coefficients to x2, that is what the decision variables, right. So, means x1 is the decision variable and x2 is the decision variable, but now when we put say w z equal to c1 x1 plus c2 x2. So, that means c1 is the kind of item corresponding to x1 and c2 is the kind of item corresponding to the x2. So, now we means these are c1 c2 are the kind of parameters, and then accordingly we like to think about the kind of calculation of c1 and c2 through which actually you have to address the particular problem. So, that means technically what I have already mentioned. So, we have actually graphical structures or we have a simplex structures through which you can actually get the kind of solutions, and the problem must involve a single objective, a linear objective function and linear constraints, and kind of some kind of non or constant numerical values. Like in the case of predictive analytics, which we have already discussed, there itself also corresponding to a problems we have to develop a models, and the model will be this model usually like the kind of variables with parameters and the kind of linkage or the kind of relationship, and we frequently use the data to get the values of the parameters corresponding to the kind of variable through which you can actually analyze the problem more effectively. And in the kind of prescriptive analytic structure, the idea is also more or less same, and here the idea is again we have a kind of objective function corresponding to problem and then constants and the conditions, and every times whether it is objective function or constants. So, so the decision variable will be there, and then corresponding to the decision variables. So, we have a kind of constants or kind of parameters, and the whole idea of optimization or the kind of structuring is find out these parameters through which actually we can address the business problem more effectively, and then come with a kind of optimum solution or the kind of optimality through which we can actually generalize the problem, and that is the kind of basic requirement of prescriptive analytics. So, that means the whole objective of prescriptive analytics is to find out the values of the decision variable, that is actually the optimal values of the decision variable through which you can analyze the particular business problem. For instance, let us say there are two variables x1 and x2, and x1 and x2 having actually so many data points, that is to let us say past data points, and then with the help of predictive analytics develop the model and you generalize or generate some future kind of requirement for both x1 and x2. So, now altogether starting with the actual information, that is the past information, then with the predictive analytics we have actually future information. So, that means we have a big pool of data for both x1 and x2 and the kind of combination. For every x1s there must be x2 value. So, that is the kind of structure through which descriptive analytics, predictive analytics can work together. And then in the prescriptive analytics, since x1 and x2 for each items, whether with a particular cross sectional structure or time structure, for each cross sectional unit or each time series unit, we have values of the variable for x1 and x2. So, that means x1 set of more number of variables, and x2 is also set of more number of variables. Now, so far as the optimality is concerned, which specific combination is perfectly required for the particular business problem, so that the business can be addressed more effectively as per the particular business objective or the particular business requirement. And that is what the kind of main agenda, and through which you can actually look for the kind of structure. And in fact, this is a kind of simple example, and through which you can actually understand the linear programming structure. And the idea about the linear programming structure is actually you have a problem, and the means that is the kind of theoretical background or the kind of structure of the kind of business. And since we are in the kind of analytics game, and we cannot or we are not in a position to solve the problems or the kind of we cannot reach the kind of requirement until unless you transfer the theoretical structure into a kind of model format. Again, whether it is a kind of prescriptive structure or predictive structure or the kind of inferential structures. So, we need a kind of model through which you can use the data and then use the kind of technique, then we can create a kind of flexibility environment or flexibility structures, and within the flexibility structures we like to find out the kind of best choice through which you can address the business problem more effectively, and that is what the main agenda of this particular unit. And let us start with a simple game here and or simple problem, business problem. Suppose a manager wants to know how much of each of the 3 products, call them product A, product B and product C. He should tell his production department to produce in order to maximize the profit obtained from those products. So, that means technically, so it is the kind of 3 products game, and so the this is actually production and operation kind of environment. So, when we talk about a kind of business structure or business problem, the ultimate aim is to obtain profit and the kind of revenue maximization, profit maximization, cost minimizations. So, all these things are usually in the kind of doorsteps in the structure of any kind of business. And here also same things in the kind of a production game. So, we have a kind of 3 products. So, we are interested to know, so what should be the volume of these 3 productions, so that profit can be optimized. And obviously, when there are 3 production production case, and we need a kind of combination, linear combination of these 3 products A, B, C, through which actually the business firm can be at the optimum levels, that is the to have optimum profit. And obviously, so it is actually under the particular couple of constraints, and in this particular case we have actually the structure is all these 3 products will be through different departments, and accordingly we have a labor time, material time and machine time to produce this kind of products. So, the manager wants at least 40 units of product B to be produced and exactly 30 units of product C to be produced, and he also recognized that the resulting quantities cannot be less than 0. So, that means obviously, since it is a kind of production process, so the output cannot be 0. If output will be 0, then the entire game is over there, and again output cannot be negative. So, that is how in the linear programming format. So, we put the restriction with respect to let us say A, B, C. So, we can transfer into or we can actually symbolize x 1, x 2, x 3. So, that means x 1, x 2, x 3 are decision variables. So, now whatever may be the shape of the problem, whatever may be the structure of the problem, the values of the decision variables in this case here x 1 and x 2, x 3 cannot negative. Yes, of course, sometimes it can 0 or sometimes it can be more than 0. So, that means when we are looking for a kind of combination and looking for the kind of optimality where profit can be the high level. So, that times, so there is a high chance that the particular values of the variable 0 will be 0, and obviously, if particular variable will be 0, the other case it will be very high. But the more feasible structure will be all these items will be there in the system and all will be in a kind of positive structure. So, that means we need to connect with a kind of structure where all the production can take place, and then the optimization structure can happen. So, that it will be win-win kind of situation. So, that a particular product cannot be discarded, and then we will look for the optimum solution. So, it is not so easy to find out the kind of structure, but still we are looking, that is how analytics are the kind of business analytics will help you to understand the particular requirement and the kind of need. So, now in this context, so our objective is to maximize profit on products A and B, A, B, C, and subject to the following kind of requirement. So, the labor hours used cannot exceed the available labors, that is what we have here, and then the machine time used cannot exceed the available machine time, and produce at least 40 units of product B, produce exactly 30 units of product C. Then the quantity produced cannot be less than 0. So, these are the kind of conditions. So, that means from this particular problem, so it is very much clear that so in real life scenario, particularly in the kind of business kind of scenario, so we have lots of conditionality, right. So, that is how prescriptive analytics and the kind of optimization tools like linear programming a problem is having actually key requirement, and because when there is a kind of conditionality and the kind of restrictions, and these tools are very effective to address the problems and come with a kind of solutions as per the as per the particular business requirement and the kind of management requirement. So, now corresponding to this simple structures, so the linear programming can be a linear programming model can be analyzed, and that is with respect to objective function, values of the decision variable, constants, parameters, non-negativity, and some kind of assumptions. So, with this we will stop here, and in the next class we will continue with this particular discussion, and then we will address the particular business problems with linear programming format. Thank you very much. Have a nice time.